In this video I'm going to show you how to do AQA A-Level Maths from June 2018, Paper 2, Question 13. My name is Sunil Tanner, I'm a tutor and author. I'm available for one-to-one tuition. I live in Buckinghamshire, England, or I can do online tuition. In this question, use G equals 9.8 meters per second square. A boy attempts to move a wooden crate of mass 20 kilograms along horizontal ground. Coefficient of friction between the crate and the ground is 0.85. The boy applies a horizontal force of 150 newtons. Show that the crate remains stationary. So if we imagine the situation, there is the ground, here is our crate. We know its mass is 20 kilograms, so the weight is 20 G. There will be a reaction force upwards. There will be friction, say in this direction, if the boy is pulling it in this direction. So there's the boy. And those are the forces that are applying on the crate. So the first thing that we can do is see that Newton's first law applies in the vertical direction. And Newton's first law says a body remains at rest unless external force acts upon it, or it remains at constant velocity unless an external force acts upon it. So in this case, we know that the crate is not sinking into the ground or taking off from the ground. So we know that the reaction force is equal to 20 G. So reaction force is 20 G, which means that mu R, which is the friction, is 20 G times 0.85, which is the value of mu. And if we put that in the calculator, we find that the friction is 166.6, which is the friction force. The thrust in the vertical direction, the horizontal direction from the boy is 150 from the boy. And we can see 150 is less than 166.6, which is not enough to overcome friction, so therefore the crate remains at rest. And that completes part A of the question. There's a second part of the question now. Instead, the boy uses a handle to pull the crate forward. He exerts a force of 150 newtons at an angle of 15 degrees above the horizontal as shown in the diagram. Determine whether the crate remains stationary. Okay, the crate still weighs 20 kilograms, so its weight is still 20 G. The reaction force may be slightly different now, or will be slightly different, because if you look at the force applied by the boy, it includes both the horizontal component, he's trying to pull it forward, and he's also trying to lift it off the ground. So let's call it P instead of R, because it's a different reaction force. Yeah. The friction will now be mu P, and what we need to do is split this 150 newtons into a horizontal component and a vertical component. So the horizontal component will be 150 cos 15, and the vertical component will be 150 sine 15. So in the vertical direction, again, we can apply Newton's first law. It's not sinking into the ground or taking off. So we know P plus 150 sine 15 is equal to 20 G. So we can use that to work out what P is. P will be 20 G minus 150 sine 15, which if we put that into our calculator, we get 157.177. We can now work out what the friction force is, mu P, which is friction, which will be 0.85 times the value of P, which we had already calculated, which comes out to 133.60 newtons. I should probably put the units in here as well. What about the horizontal force from the boy? Horizontal from boy is 150 cos 15, which is, if you're going to put that in your calculator, it will come to approximately 144 144.89 newtons. 144.89 newtons is bigger than 133.60 newtons, so overcomes friction, which tells you that the crate moves. And that completes question 13.